Assalamualaikum warahmatullahi wabarakatuh. To our lecturer, Dr. Nur Ain Izzati binti Muhammad Yasin. In this video, we would like to present about our project. But before that, I would like to introduce about our member in this group. The firstly is Nur Zuhaira Atika binti Zaharuddin. The secondly is Nur Husnina binti Zuraini, which is me. The thirdly is Nur Vahida binti Radilah. The fourth is Nur Fatin Najiha binti Idris, and the last but not least is Nur Nisa Fatini binti Ruzaimi. Okay, the next slide, I will pass it to my friend. Thank you.
Hi, Assalamualaikum. Today I want to present my project structure. Is my part executive summary. This bridge has overall span with total length 8,000 mm and the total height of the bridge is 4,000 mm. This bridge is supported by a roller and a pin support which will create 3 support reaction. This bridge is then loaded by 3,000 kN load at the middle of the bridge where is exactly at joint F. The second point, our objective is to analyze and calculation the internal force for each member of the truss and to find the deflection of the truss bridge after loads are hanging. To find the internal force of truss member, 3 methods can be used, which are method of joint, method of station and alternative.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Vahida binti Radilah and I'm going to present introduction. Bridge is a structure that spans horizontally between support, which function is to carry vertical load. It provides passage over a gap or a barrier such as river, roadway that are difficult or impossible to cross. In the term of civil engineering, bridge is a connecting structure that creates bonding between different disconnected parts of certain places. Bridges consist of many types such as arch bridge, beam bridge, truss bridge, cantilever bridge, suspension bridge, and cable stayed bridge and tied arch bridge. For our project, we choose to analyze a truss bridge specifically for Warren truss. The Warren truss uses equilateral triangle to spread out the load on the bridge. The equilateral triangle minimizes the forces to only compression and tension.
My name is Nur Fatin Najiha binti Idris, metric number CF20014C. For part 1 in calculation, we need to classify the type of truss. Firstly, determine the number of member, joint and reaction. So, the number of member is 29, the number of reaction is 3, and the number of joint is 16. Using formula M plus R equal to 2J and complete the formula. So, 29 plus 3 equal to 2 multiplied by 16, and the answer is 32 equal to 32. It classifies as statically indeterminate.
Assalamualaikum. My name is Nur Nisa Fatini binti Ruzaimi, matrix number CF200210. I'm going to explain about part 2. In this part, we do the calculation of internal forces by using method of joint. For the virtual load, the calculation also using the method of joint, where the orange color represent the tension value, while the blue color represent the compression value. After we finish the manual calculation, we calculate the internal forces and virtual load in the software. Lastly, we make the comparison between manual and software calculation for internal forces and virtual forces. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Husnina binti Zuraini and my metric number is CF2030. So this is about the comparison value of internal forces for real load. So the first step is we must to calculate the software calculation and manual calculation. We must to minus and then we can get the different result. After we get the different result, we must to find the percentage difference. So after that, we must to calculate the average percentage by total of percentage difference, which is my negative 336.80 divide by the total of member, which is 29, so we can get the negative 11.61. Okay, next is the comparison value of internal force for virtual load. To find the average percentage, we must to divide by software calculation and manual calculation. So here is a negative 0.2498 divided by negative 0.25, and we can get the total of average percentage is negative 0.99. Okay, based on the comparison that has been made, there are big difference between using manual calculation and software. From the table shows comparison value of internal forces for real load and comparison value of internal force for virtual load. There are few factors that influence the outcome of the manual calculation and the software. Firstly, this could be due to assumptions we made during the manual calculation as well as calculation errors. Following that, there may be a few errors that occur during the calculation, resulting in different answers for both methods. Based on both methods, we can conclude that the difference is due to the value of the modulus of elasticity used in both calculations. However, software is faster and saves more time than manual work. Thank you from me.
Okay, next I want to present my discussion. Okay, first point, we had understood the value and importance of building a durable bridge based on the project, then had been finishing able to determine and design the suitable type of bridge in order to experiment on the efficiency of withstanding internal force or loads placed into the system. The second point, ability to identify and calculate tension or compression force if applied into structure member has been fully released through the multiplied inspiration of arrangement of the structure member. Okay, the third point, the manual and comparison calculation produce slightly different result. Why different result? Because the calculation due to the method of calculation show as using the wrong formula for calculating the data incorrectly. And the last point, as a student in the field or in civil engineering, it is critical for us to understand deeply what makes a structure function efficiently without being prone to failure of the sake and safety of future use and components.
Okay, next is conclusion. All of the group members were able to gain new experience in building and designing our bridge as a result of this project. At the same time, all of the group members can practice the bridge theory and calculation. We also recognize that the design of a bridge to be built has a significant impact on its strength. Aside from that, the load distribution between the trusses must be uniform in order for the bridge to be stable when load is applied. By following our lecturer's recommendation, we will be able to meet all of the project's requirements. We were able to measure and classify the type of force delivered to each member by personally measuring it and utilizing Limpro software, which help us understand deeper load distribution in a structure. Okay, next, we also learned the importance of suitable scheduling must be taken in terms of design and analysis of the load put to the structure to become a stronger bridge. Each part's joints must fit as closely as possible to each other. Fortunately, all of the participants in this project have agreed to work together to complete it. Thank you.